Okay, in this video we are going to solve quiz number 4 and also go over the midterm 1 review. Now I gave you this table, okay, and I asked you to construct 4 histograms, one that's represent for this frequency table using the class boundary and the midpoint, and then we use another 2 histogram to represent for the relative frequency, and also using the class boundary and also using the midpoint. Now first, let's just ignore the relative frequency, just focusing on this original table. I have the movie ratings 0 to 2. We have 1, 2, 3, 4, 5 classes, so you are expected to have 1, 2, 3, 4, 5 bars, right? And after we know that we have 5 bars, the second thing we have to consider is how do we label the x-axis. So there are 2 cases. We can use either the class boundary or the midpoint. So first, let's try to use the class boundary. So remember, the class boundary, usually I take half a point below the lowest value of the first class, and then I take the average of 2 and 3, which is 2.5 for the next one. And then the same thing, between 5 and 6, I add them, I take the average, which is 5.5. 8 and 9, I add them, I take the average, which is 8.5, and so on. Now, first, we have to plot the class boundary. So I have 0 is lowest, so half of that value be below that, which is minus 0.5. And the next one is between 2 and 3, which is 2.5. And then 5 and 6, which is 5.5, and so on. And the frequency, from 0 to 2, which is falling in the first class, which is 20. So I charge to 20 for the frequency. The same thing for the second class, 14. I charge up to below 15 a little bit here. And 6 to 8, but I'm drawing for the third class, which is 5.5 to 8.5. We are using the class boundary. This case 15, so I draw approximately equal to 15 here. Now the second case is using the class midpoint. Remember, between 0 and 2, we add them, we divide by 2, we got 1. The same thing, 3 and 5, we add them, we divide by 2, we got 4, and so on. So 1, 4, 7, 10, 3. Just add a 2 number and divide by 2. You got the midpoint. So I got what? Exactly the same thing here, but instead of labeling the class boundary, I'm now using the class midpoint. 1, 4, 7, 10, and 13. So I just draw in the middle. 1, 4, 7, 10, and 13. Pretty simple. Now we have 2 cases for the frequency. The second case I asked you is for the relative frequency. Remember, the relative frequency is the percentage. So the first thing is you have to find the total frequency. So 20, 14, 15, 2, and 1. When you add all of them together, you got 52. Now the relative frequency of the first class is 20. We have to take 20 divided by the total frequency, then multiply by 100%. That gives you 38.5%. Now the relative frequency for the second class is 14 divided by the total frequency, 14 divided by 52, then multiply by 100%, give you 26.9%, and so on for the last 3 cases. So we also have 2 cases, the one that using the class boundary and then another one using the class midpoint. So instead of having 5, 10, 15, 20 for frequency, now I can see that the highest I can get is 38 or around 40%. So I have 40, 30, 20, and 10. And using the same class boundary, negative 0.5, 2.5, the same thing here. But I know that the first class is 38.5, so it joins up to close to 40. The second class is what, 26.9. So now I draw the second bar around 26.9 around here, and then the rest should exactly the same thing here. Now we copy this plot, the same thing here, but instead of labeling the class boundary, I'm now using the class midpoint. 1, 4, 7, 10, and 13, the same thing here. So that's why totally we have all 4 histograms. 2 for the frequency case, and the other 2 for the relative frequency. Now let's move on to the second question. So I give you the data. This is in millions of dollars that we got for the first 14 days after the movie was released. And notice that the first day was on Wednesday, right? So Wednesday, Thursday, Friday, Saturday, Sunday, Monday again, and so on. Now we need to construct the time series graph first. So the time series graph, we are indicated here that we have 14 days, so we have 1 up to 14 days. So the x-axis is in day, and the y-axis, this is in millions of dollars. So the first day I have what, 58 million, so I draw 1 and close to 60. The second day I have 22, which is around here. The third day I have what, 27, and then the fourth day I have 29, and then the fifth day I have 21, which is go back down here, and then I just connect all the dots together. This is called a time series graph. Now they also asked us to suggest an explanation for the fact that the 3 highest amounts are the first, the third, and the fourth values. Okay, the first day is Wednesday. Now the third day is what? Is Thursday, because Friday. So Wednesday. The second day is Thursday. The third day is Friday. The fourth day is Saturday. Now the reason that we have the peak for the first day and the third day and the fourth day, because basically the first day is the Wednesday, and you know that the day that the movie is released, people are excited to watch the new movie, so they tend to watch a lot during the first day. Now the second day on Thursday, I don't think people will watch a lot of movie. They have to wait until the third day and the fourth day, which is Friday and Saturday, which is the weekend days, so they can spend that time and watching the movie. They don't have to care about the work, school, anything. So that's why from this case we can see that the first day there's a peak, and then the third day and the fourth day we also have the high rates because they are on the weekends, so people have more time, free time to watch the movie. So that is a good explanation for the behavior of this graph. Now we are finishing the quiz 4. I'm now reviewing for the midterm 1 study guide. So remember, the midterm will be multiple choices. So we have 28 questions, but I only count 25 questions, and 4 points each, which will give you 100 points total. Now the rest 3 questions are for extra credit. If you can do it, you get extra 4 points each, which is 12 points total. And if you can get correctly all the questions, you should have a maximum score of 112 out of 100. Okay, so here are the topics that I would like you to review carefully. So let's go over this quickly. Observational and experiment. So remember, when we collect the data, if we just observe the data and we collect that, we call that observational data. Experiment is that before we collect the data, we attempt to modify them, do something about that, and then we collect the data. That means we have been doing something to the data before we collect them. So make sure you can distinguish between the differences between those two. Now, another type question is, I give you a statement, a situation. Now, I want you to identify for that case whether that is a simple random, systematic, cluster, stratified, or convenient. Remember, simple random. What is simple random? So, simple random is that, for example, I have n subjects. Now, every time I collect that n data from a population, the same size of n data have to have an equal chance of being chosen. So, for example, in this California state, right, when I pick 10 people at a time, randomly, make sure that any 10 people I pick will have the same equal chance of being chosen. So we call it simple random. Now, systematic, that means we pick from a population, from a sample, from a region. We pick one subject, and then we count maybe the next 3. We skip the next 3, then we pick the 4th one, and then we skip the next 3. We pick the next one. So if you imagine, I have 100 people, right, standing for you to pick them. So I pick the first person, I skip the next 2, then I pick one more, then I skip the next 2, I pick one more, I skip the next 2, I pick one more. That is called systematic. That means you pick them in the order of the K order. Okay. Now, cluster is what? Cluster is from a population. I divide the whole thing into small sections. Now, those small sections I pick randomly. So, from a large population, I pick randomly one person from a small section that I divide them before. So, for example, in California, right, I divide the states of California into 20 different areas. Okay, now I pick randomly 5 areas, and I take all the data from each of the area of the 5 areas that I pick. So you divide that into small sections, but when you pick them, you pick the whole section with you. Okay, now stratify. What is stratify? That means first you subdivide the population into at least 2 different subgroups. Now, inside each of the subgroups, make sure they share the same characteristic. Maybe the gender, the ages, education, something like that. Color, okay? And then you pick a sample from each group, okay? So first, the whole population, I divide them into small subsections, but make sure that in each of the subsection, they share the same characteristic. And now I pick one from each of them. Okay, convenient is the last one. Is pretty simple. You just have to take the data that are convenient for you, right? You don't have to go to all the way to different area to collect the data. You just have to go to the one that you think is save your time, is convenient for you. We call that convenient data. Okay. The same type question, I give you another statement. I ask you to identify if that is cross-sectional, prospective, or retrospective. Now, cross-sectional is the data that we collect only one time. Prospective is the data that we will collect in the future. Retrospective is the one that we go back, we check our history, we check our previous data, and then we collect that. For example, you go back to your interview record and then you collect the data. Okay. Random sample versus simple random sample. So random sample is that every person, every subject has an equal chance of being chosen. Simple random sample is every n subjects, every n group has an equal chance of being chosen. 4 levels of measurements. Remember, we have 4 levels of measurement. What is it? Ratio, interval, ordinal, and nominal. Remember, ratio is what? There's a natural zero starting point. And when you take the ratio, we have some meaning. Okay? For example, the height, the length, the distances, the volumes, they all have the zero starting point. Interval, the differences are meaningful, but there is no natural zero starting point, and the ratio are meaningless. So when you talk about your body temperature, you cannot have zero temperature, or if you say that you have a year of zero, which doesn't make sense, which is nothing, right? Ordinal, that means your data can be arranged in the order, but when you take the differences between them, it won't make sense. For example, you have your ray A, B, C, D, right? You can arrange them in the order from higher to lower, A, B, C, D. But if you take A, subtract B, you don't have any meaning for that. Okay. Now, nominal is the last one. Nominal is that you cannot arrange them in the order. For example, color, black, yellow, white, right? They don't have any meaning. They don't have the priority. You cannot arrange them in the higher to lower rate. You cannot do that. That's called nominal. It's only for calorie. You just have to put them in the calorie. That's all. And we can arrange them. Okay. So how to get a given value if given a percentage of the total value? So for example, I said that I have $2,000. Now I want to take 50% of that. What would be the value? So you take 0.50 multiplied by 2,000, you get $1,000, right? Qualitative versus quantitative. Remember, qualitative is the descriptive data. Quantitative is something you can count, you can measure, you can describe in terms of the number. Discrete versus continuous. So discrete is only take a certain value, the whole number, something like that. For example, if you say your age, right? Usually we would say that I am 14 years old, I am 15 years old, I am 16 years old. You don't say to people that I am 14.526 years old. I am 15.989 years old. We don't usually say that. We don't say that. It doesn't mean anything, right? And continuous is it can take any value for the number. For example, if you're talking about your weight, if you weigh your whole body, you can say that I am 125 pounds, 0.26, right? Or 100.101 pounds. It can take any value, so it's continuous on the number line. Now, sample statistic and parameter versus population. Remember, S go with S, P go with P. So sample is just a group of data from your population. So population is the whole thing. Sample is just a small area of the population, and statistic is the key element to describe that sample, and parameter is the key factor that represent for the whole population. Now you should be able to know the shape of the scatter plot, the bar plot, the histogram we already know from the quiz, and how to use the dot plot. How does it look like? For example, if I click on this one, right? I know this is the dot plot. So for example, it's asking for how many days had a temperature of at least 16 degrees. We know that 16 is here, right? There are two dots. That means there are 2 days we have 16 degrees, and 18 also 2 days. 19 is on only 1 day. So that's how the dot plot should look like. And be able to find the class midpoint, you already know that from the quiz. Be able to find the class boundary, it's easy. Be able to find a cumulative frequency. Okay, let's go back here. The definition for the cumulative frequency is the total of a frequency and or the frequency so far in the frequency distribution. Now, for example, I said the score of 1, there's 2 people. The score of 2, there are 5 people. But the cumulative frequency now, we take the current value, we add to the previous one, which is 5 plus 2 give me 7. Now, score of 3, I have 4 people got the score of 3. But for the cumulative, score of 3 is 4 people. But for the cumulative frequency, we take this current value, we add to the previous 2. So 4 plus 5 plus 2 give me 11. So that's how the cumulative frequency, that means you take this current value and you add up to all of your previous value. Alright? So be able to find the variance of a given sample. So it's easy. Variance is just what? It's just the square of your standard deviation. Now let's go back to the standard deviation. Back here. Okay. So I have these 4 numbers. I want you to find the standard deviation. Remember, the standard deviation, the formula, you take the difference between the data point and the mean value, then you square that for each of them. Then you add all of them together. Then you divide by one less than the total number of data. Then you take the square root. That will give you the standard deviation. Now the variance is just this whole number square. That's all. Alright, so that's be able to find this. Be able to do the GPA, the weighted rate from the example in the class. I solve you 2 examples in the class, so you should be able to find that. Be able to find the mean from a given set of data. We add all the data, we divide by how many number of data we have. Find a median value. That means the value in the middle, right? So 50% will be above that, and 50% will be below that. Find a range. You take the highest value, subtract the smallest value. And the most is what? The most is just the number that occur the highest occurrence in that data set. So for example, I have 2, 5, 6, 9, 10, 2. So the most for this data set is 2 because 2 appears 2 times, and this is the highest. Everything else just has one appearance. Okay, so that is the mod for this data set. Now one last example I want you to practice is this one, and this is the problem for the weighted rate. Okay, so let's go down here. So remember, we have the formula for the weighted score. The weighted mean. So the weighted mean is we take the sum. This is the sum of the weight multiplied for each of the data and divide by the sum of all the weight. So what does this mean? Now let's go back to here. Let's go here. Oops, sorry, that's not. what I want. Let's go back here. Okay, wait. Alright, so I have x bar equal the sum of x multiplied with the wave and then the sum of all the weight. This is the formula for the weighted mean. Now we have a question. A student earned the rate of 84, 78, 84, and 72. This is the score for her 4 tests. Now she also earned the rate of 78 on the final exam, 86 on the class projects, and all the homework assignments. When you combine them together, she got 87. Now this 4 tests here will count for 40% of the whole rate. The final exam is 30%, and the projects is 10%, and the homework is 20%. Now we want to ask for her weighted mean rate and round this to 1 decimal place. So remember the weighted mean rate. So they are asking you for the weighted mean rate. So if they are asking for the weighted mean rate, the key here is the rate, which is a number, not a percentage, right? A number. So we will have to find a weighted for the rate, which is all of these 84, 78, 84, 86, something like that. So x here is for the rate, the weighted mean rate. X bar is the weighted mean rate. So the x here, inside here is the data. So x here is the data. So it has to match with the one that we are looking for, which is the rate. So x, the data, should be 84, 78, 84 again, 72, 78 for the final, 86 for the class project, and 87 for the homework assignments. Now this is the data x, which is the rate, right? Because x bar is the weighted rate, but x is the rate data. Now w is the weight. So we know that we have the weight of 40%, 30%, 10%, and 20%. So the weight we have here is 40% or 0.4, 30% for the final is 0.3, 10% is what? Is for the projects 0.1, and 20% is for the homework 0.2. Now we have w, we have x. So you know that 87 is the homework, right? It has to go with 20%. 86 is the final. It has to go with 10. Oh, the project, it has to go with 10%. 78 is the final, is go with 30%. Now the 4 tests is go to 40%. But here we have 4 numbers, 4 tests, and all of these will be count for 40%. So how do we make the 4 score here to go with 40%? The first thing is because each of these 3 is go to the 3 value for the weight here, but now we have 4 of them, but we only want 1 to go with 0.4. So which number do we take? The only way we can do is we have to take the average of these 4. So the average of the x should be 84 plus 78 plus 84 plus 72, right? Take the average divided by 4, and let's see how much for this one. 84 plus 78 plus 84 plus 72 divided by 4, that's give me 79.5. So this number will go to 40%, right? Instead of taking the 4 of them, we have to take only 1, and the only way we can do that is we take the average of all of them. Now we are ready to plug into this formula. So the sum, alright, the sum of each of the data So the first one is 79.5, which is 40% for the weight. So 79.5 multiply with 0.4. Add to the next one is 78. Let's go to 30% for the final. So 78, 0.3 multiply 0.3. The next one, 86. Let's go with what? 10%, 0.1. And 87, let's go with 20%. 20%, 0.2. Divide by the sum of the weight, W. If you add 0.4, 0.3, 0.1, 0.2 together, it should give you 1, because of this comprise up to 100%. So if you do this calculation correctly, I believe you should get 81.2. Let me double check. So yes, if you do this correctly, then you should get 81.2. Now, this is the weighted mean or X bar. So I asked you guys to find the weighted mean rate. So the rate should be some number, not the percent. Percent is the weight, but here is the weighted rate. So rate is the number. Make sure you give me a number, not a percent. Okay, so the number that is consistent with the rate we got here. So something close to low value here. Alright, okay, so that is the one example for the weighted rate. And make sure you know the other example in the class how to calculate the GPA. Okay, so that's the end of your review for the midterm.